the shocking truth about why life began on Earth. What if I told you the most remarkable story in the universe started on a barren, molten rock spiraling through space? A rock that, against all odds, became a cradle for something extraordinary. Life. But how? Why? And what does this stunning event billions of years ago mean for us today as humans? Prepare to uncover the truth about how life began on Earth, the science that unravels this mystery, and how understanding life's delicate emergence helps us navigate our future in the vast cosmos. Let's trace this incredible journey from the past to the present and beyond. Earth didn't always look like the vibrant blue planet we know today. Go back about 4.5 billion years and you'd find yourself amidst a molten inferno, a raging landscape of volcanic eruptions, toxic gases, and meteors pounding the surface. It was a world that seemed utterly inhospitable. And yet, hidden within this chaos was the seed of something transformative. Life. As the planet cooled, oceans began to form, creating a laboratory unlike anything else in the solar system. Marine environments combined with volcanic activity and energy from lightning storms provided a rich chemical playground teeming with potential. But potential alone wasn't enough. The question remains, what sparked life into being? Scientists have spent decades trying to answer the elusive question of how non-living matter transitioned into the first living organism. The journey to understand this phenomenon has led to groundbreaking theories, each offering a fascinating piece of the puzzle. One of the first and most famous theories was the primordial soup hypothesis. Imagine ancient oceans brimming with organic molecules churning under the influence of ultraviolet radiation and electrical storms. This turbulent mixture wasn't random. Such conditions allowed basic compounds like amino acids, often called the building blocks of life, to form spontaneously. In 1953, scientists Stanley Miller and Harold Urey tested this idea in their famous experiment. They recreated an early Earth atmosphere in the lab and exposed it to electric sparks to simulate lightning. Astonishingly, the experiment produced amino acids, suggesting that life's precursor molecules could arise from non-living material under the right conditions. A striking result, but life's story doesn't end here. While the primordial soup theory explains how essential ingredients might have formed, another hypothesis shifts our attention deep below the ocean's surface, to hydrothermal vents. These fiery underwater volcanoes spewing mineral-rich chemicals provide an ideal setting for life to emerge. At these extreme depths, raw chemical energy meets the right environmental conditions to trigger complex reactions. Some scientists believe that the first living organisms, simple microorganisms, could have evolved around these vents, sustained by chemical energy rather than sunlight. These ecosystems, relying on chemistry rather than photosynthesis, still exist today, offering us a glimpse into life's possible beginnings. An even bolder theory asks us to look beyond Earth itself. Could the building blocks of life, or even life itself, have originated in space? The panspermia hypothesis suggests that amino acids, or simple microorganisms, were carried to Earth aboard meteorites, seeding the planet with the precursors to life. This idea isn't as far-fetched as it sounds. Analysis of meteorites has revealed that organic molecules, such as amino acids, can exist in space. Could life, then, have a cosmic origin? While panspermia may not explain how life began, it tantalizingly suggests that Earth's life story might be intertwined with the greater universe, linking us to distant stars. Science doesn't stop at how life's ingredients were formed. It also investigates how these ingredients began organizing themselves. At the heart of this investigation is something called the RNA world hypothesis. RNA, a molecule similar to DNA, could have been the key to life's self-replication. Unlike DNA, RNA can act as both a genetic material and a chemical catalyst, making it an ideal candidate for the first self-replicating molecules. Once RNA molecules learn to copy themselves, they set the stage for evolutionary processes that would eventually lead to complex life. In this way, life's story becomes a tale of humble beginnings. Simple organic molecules blindly stumbling into self-replication paved the way for the diversity we see today. The beauty of science is its reliance on evidence, and plenty of it helps bolster our understanding of life's origins. Experiments like Miller-Urey demonstrated the formation of amino acids under the right conditions, but nature provides even more clues. Fossilized microbial mats billions of years old give us a glimpse of Earth's earliest life. Moreover, extremophiles, organisms that thrive in hostile environments such as boiling thermal springs or radioactive waste, show us how life can adapt to extreme conditions echoing the environment in which it likely began. Astrobiology, too, offers tantalizing clues about life beyond Earth. Mars, Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, all contain conditions that might harbor signs of early life, or answer new questions about life's origin. If life's emergence on Earth was a series of extraordinarily rare events, where does that leave us? We, humans, represent one outcome of billions of years of evolution, a product of the very forces that sparked life billions of years ago. Understanding our origins connects us deeply to the story of our planet and the cosmos. Life didn't have to exist, but it does. And humans, blessed with consciousness and curiosity, are the only creatures capable of asking, why? Reflecting on life's origins drives us to consider our purpose and our responsibilities as stewards of this rare, fragile world. Science can tell us how life began, but it's up to us to explore what it means. Was life an accident, a cosmic inevitability, or was it part of something larger, a grand structure woven into the fabric of the universe? These questions tread into deeply philosophical territory. Some see the emergence of life as proof of sheer chance, a delicate balance of natural laws and random outcomes. Others interpret it as evidence of purpose, something ingrained in the universe itself. Either way, understanding life's origins forces us to reconsider our priorities. If life is fragile and fleeting, then every moment matters. If life is a cosmic constant, perhaps our role is to preserve and propagate it. While life's journey began 3.8 billion years ago in Earth's chaotic oceans, it hasn't stopped. Evolution marches on, and today, humanity sits at the center of life's next chapter. But where is it going? With advancements in synthetic biology and artificial intelligence, humans now have the tools to rewrite life itself. We're no longer passive participants in evolution. Instead, we're becoming architects of new forms of life. Biotechnology, for instance, may offer solutions to diseases or even create entirely new organisms. Will we create artificial life with its own sense of purpose? If so, will it inherit the questions that haunt us about meaning and existence? As our curiosity extends beyond Earth, the idea of bringing life to other planets seems plausible, even necessary. Mars and Europa, for example, are tantalizing targets for studying life's potential in other environments. Could humans serve as the agents of life's spread, exporting Earth's story to the stars? At the same time, expanding life beyond Earth raises ethical dilemmas. Does life on other planets already exist? And if so, should we leave it undisturbed? How do we reconcile our pursuit of discovery with the responsibility to protect life in all its forms? Amid exploring distant planets and designing synthetic organisms, let's not forget our roots, Earth. The conditions that allowed life to flourish here are unique and fragile. Climate change, habitat destruction, and pollution threaten the very ecosystems that sustain us. If life's origins teach us anything, it's that survival is precarious. We must safeguard the only known cradle of life, because it's where our story began. The story of life on Earth is as much about chemistry and evolution as it is about wonder. From primordial oceans to self-replicating molecules, the emergence of life reveals a complex interplay of chance, necessity, and resilience. For us humans, understanding this journey prompts awe. Against incredible odds, we exist. And with that existence comes responsibility to protect life, to explore its potential, and to give it meaning. So, as we reflect on this remarkable story, where life began and where it might go, let's ask ourselves, if life arose from chaos billions of years ago, what future might we create? Life's past holds many truths, but its future remains in our hands. What legacy of life will we leave behind?